Okay, so it's day 34 of 100 Days of ML, and I'm going to be continuing data pre-processing today. So yesterday, where I left off was I finished up changing preprocessing.py, and I also tested the prototype in, I think, preprocessing test in the Jupyter notebook, and I got to the point where I was calling transform using the preprocessing function, but there was an issue because while loading in the preprocessing function from preprocessing.py, there was an import error. And I think that's because of how Jupyter Notebook is built. So what I'm going to try to do today is I'm going to run the container, and I'm going to directly run the ML pipeline locally using local runner and see how that outputs on the terminal. So I'm going to navigate to directory and launch the Docker container. So just to double check on text ML and under pipelines, I think where we got was we received an error when running context.run. For some reason, it just wouldn't display the output for transform. However, if we run something like transform directly, it would display an output, but everything would be empty. Let's check this again. That gets an error, but yep, here we go. So we got this module file, module not found error. And that's because in preprocessing.py, it can't import from models for some reason. So this line of code from models import constants, where I'm trying to import constants.py, is not working within the Jupyter notebook. There's some sort of import error. In terms of code and syntax, I think everything is correct. It's also logical. Actually, I don't think I need to specify from models. Wait, I think I just might have. From models. Is it feature system? Which line from models import constants? I just changed it. And I also think it does import from models, import preprocessing. Because I think when this is loaded, it loads from the root. So there shouldn't be an issue when importing it as from models. Either way, I'm not sure why the code here didn't get updated. So what I'm going to do is just run this in the CLI version. And I'll have to open up TFX to see how to run the pipeline. This is build custom local. Here we go. So I have to create and then run, because every time the container, it doesn't really store, I believe. I have to create it every single time. Navigate to ML. Okay. I might have not included the transform in the pipeline, so I have to add it to the component, I believe. Here we go. Yeah, I have to uncomment this. And I'll remove this piece of code here. So preprocessing comes here. Preprocessing, and I use transform and text standardization to vectorize, basically to pre-process the code. And I use text vectorization imported from Keras preprocessing. So let's try this again. And run. Ideally, I would have figured out how to like write code to get like display the outputs. Like if I could do that, that would be great. Like every time I run the container, I mean the pipeline, I get new outputs and it gets stored into TFX pipeline output. For example, like right here, we got transform, the outputs for transform. We got an error though. No module name constants. Oh, okay. I realize what's going wrong here. From models, import features, and then features. No, I don't understand what's going wrong here. Okay. I think I figured it out. So here, I think when I call my constants, I'm using constants dot. Here, let's remove this and this. And then I can go from models import constants. But yeah, ideally, I want to figure out how to display the outputs that are stored in the TFX pipeline output. That would be great. So let's create and run this again. I'm not sure if I have to create it every single time, or if I just have to run the pipeline to refresh it. I'm not too sure, but I'm taking the safe bet and just creating it every single time, compiling it, recompiling it. Okay, now it's saying text not defined. What was the error here? I think it's the same error. Wait, it's a name error this time. Text not defined. Oh, I did not import typing. Okay, let me try the Jupyter Notebook because I think the Jupyter Notebook should work now. I forgot what it was to run all cells. Run all cells. Is there a shortcut for that? There's no shortcut for it. Why didn't it run? What the heck? Run all cells. There we go. Maybe I should develop another container for Jupyter, and I can have one for CLI as well. This way I don't have to restart Jupyter Notebook every single time. Okay, I'm getting the same error here. Module not found. So it's not working within the Jupyter Notebook, regardless of the fix. So let's try recompiling and running the pipeline locally. So the only disadvantage of local DAG runner is the fact that it runs on a single machine, which is good for testing since it's fast, but if you want to scale it up, it becomes kind of hard to do that. So that's why you use orchestrations like Apache Beam, Airflow, and Kubeflow. Let's see what's wrong here. Sequence length is not defined. So it's not recognizing my constants. How was it imported in model? Here we just import constants and we're using our constants we're using it as constants dot. Okay. So I think I do have to include constants dot here. Sequence length is not defined. Sequence length is constants dot. Still having an issue here. Sequence length. Constant dot sequence length models dot constants has no attribute sequence length. Okay. Spell that differently. It takes a long time to compile and run again, over and over again. So it is pretty annoying to debug very small mistakes. Because you wait all this time and then you realize it's just a syntax error. What is it now? Unhashable type list. Text is equal to inputs. Features.keys. Unhashable type. But I thought inputs was... inputs, features, feature keys. This is how it was written over here, I believe, in the code provided in this article. Where was it? Sequence, define here, transform, applying transformations, text, inputs is text, TF, he applies TF squeeze, but either way, I mean, I get the error here. Oh wow, he's using the IMDb sentiment dataset as well. What is he trying to do? Not sure what his goal is for the models, but I think he uses BERT later on. Anyways. So you can generate statistics from TF record, which we can use here. I wonder how this numbering system works here. This line of code itself is raising issues. Unhashable type list. Okay, let's check the API here for transform. Preprocessing function passes in inputs, which is a dictionary with text and any. configuring transform component. Understanding the inputs to the preprocessing function describes operations, tensors, or the input to the preprocessing function is determined by the schema. A dictionary whose keys are feature names and whose values are a fixed length feature or a variable length feature. So each feature with shape set must be one of those or so what is wrong here? I'm just filtering out the feature keys from inputs, which is a dictionary. Yeah, so it would be input some key, and my key here would be, oh, it's because probably feature keys when I defined it in constants or features. Yeah, it's a list. So what I have to do, I'm gonna remove this. Actually, no, it's gonna cause errors in the other code. So I think I'll do something like 0. That way it just maps to the only key that I currently have, which is just review. And transform name within features takes in a key. Okay. Right, which should just be review plus xf. And returns text. Okay, that looks good. Label key is a string. That's good. All right, let's try this again. Still having an error. To be compatible with tf-eager functions must return 0 or more tensors in the compilation of get trace transform function, text vectorization. Okay, so when I'm returning vectorized layer, it's not a tensor, so it's having an issue here, which is not a tensor. Okay, let's try just pre-processing with the TFX components, something that's adaptable to TFX components. So here what they do is strip them, they standardize the token using a what? He does this custom standardization. Oh no, tokenization. How does he tokenize? He strips it here and then he uses a BERT tokenizer to tokenize. So how am I going to have to change the model? Do I need to use BERT? What's the model being used here? It's a simple model, simple sequential block with embedding, dropout, average pooling, and dropout and dense layer. So how do I modify this? That's the question. If I use the BERT tokenizer, would it be able to take in the inputs? I could try using the BERT tokenizer. But I'm not sure if the performance of the model is going to be like good, any good at all. I might as well try it. Why not? So here BERT is being loaded, returns BERT layer. Do I need that? I just need to tokenize. So I use tokens here. TF-pad, TF-reshape. Where is BERT tokenizer being loaded? Using TF-text. Okay, so let's get this imported into preprocessing.py. Remove the text vectorization. And then in preprocessing function, I'll need to load BERT, the BERT tokenizer. So somewhere over here. Vocab file path. What is this? Vocab file path. It loads in BERT. So you use the BERT tokenizer and you use, let's just not use the BERT tokenizer. I could just use a standard TFX component for pre-processing. Maps X to a vocabulary specified by. So I could get the vocabulary and then apply vocabulary. I just need to tokenize. I need something to tokenize. This finds the count. How does text vectorization work? So I pretty much have to like code all of this. Standardization, then splitting each sample into substrings, recombine substrings into tokens, usually n-grams, index tokens, transform each sample using this index into a vector of ints or a dense float vector. Let's see. Just want to focus on the pipeline without having to worry about refactoring all this code. What I could do is just follow this tutorial and use the BERT model. I wonder if he has the whole, like, he has only part 2 so far. He hasn't configured the trainer, so I'm not sure how he's going to configure the trainer. Maybe choosing text was not the best idea. So I can compute n-grams and then what? Index tokens? Associate a unique integer value with each token. How do I do that? This creates a sparse tensor of n-grams. It would be something like this. Indices values as tokens here. So after I do compute n-grams, I have to index the tokens. How do I do that? I think I can just use compute and apply vocabulary. And let's try this. So let's go back to all right, 1 sec, I'll be back. Okay, I'm back. Let's see. Where did I leave off? Right. Modifying the preprocessing function. So instead of all of this, what I'm going to do is a key in, and I'm going to use features dot, I think, feature keys, and inside I'm going to define, I'm going to build a vocabulary for this feature. So I will do output and do call the transform name function. With feature keys is equal to and I'm going to use transform.compute, transform, compute, and apply vocabulary. So on the inside, I'll have to pass in text standardization. Not too sure what OOV size is. Ngram, computer vocab. Okay, what is OV's buckets? Out of vocabulary. Is there a default value for this? It's optional, so I think I'm just not going to specify it. And vocabulary size, what's the... vocabulary file name. Is there no option for a vocabulary size? Oh, top K. Okay, hold on. Top K. Limit the generated vocabulary to the first top K elements. If set to none, the full vocabulary is generated. Optional, it's set to none. I think vocab size, what I'm using is like 10,000 in constants. I didn't specify here, but I said max features to 10,000. Okay, so gap size, I'm just going to leave it as none. Let it compute as much as it wants.